Hello, welcome to the course about geographic information systems for municipality management. At this second video, this is the second theoretical one, we are going to speak about reference systems because they are very important to manage a geographic information system. We have the cartography, the geographical information of a GIS. We have it georeferenced, so it has a location in relation to a reference system. The Earth is an irregular three-dimensional object, and its shape is similar to an ellipsoid of revolution. The actual measurements made on the surface of the Earth are, however, referred to the geoid. So when we define a reference system, we do it on an ellipsoid of revolution. The data must be transformed on the geoid to be represented on a flat. So several transformations can be applied for that. We need to define a reference system to manage the geographical information. So if we have a view in a reference system, we have to know what's the reference system of the cartography. A component of these reference systems is the coordinate system. In this case, we have two of them that are geographic coordinate systems that where a global or spherical coordinate system is based on this system is based on latitude and longitude coordinates, and the other one is the projected coordinate system, where we have the maps of the Earth into a 2D Cartesian coordinate plane. So each coordinate system is defined by an origin, reference axis, and units of measurement. We can see two different concepts for that: the CRS, or coordinate reference system, or SRS, that is the spatial reference system. When we see these two concepts in our GIS, we can know that we are speaking about the reference system. The global one, the geographic coordinate system, manages the latitude and longitude coordinates. The origin is the equator and the Greenwich meridian. The units of measure are degrees. And the other one, the Cartesian coordinates system, is local. We manage the coordinates x and y. The measurements are made in meters. The datum is the part that determines position and orientation of the coordinate system regarding to the reference system. So we can have a global datum or a local datum. For example, if the location is tangent to the surface in a local area, for example, for Europe, one of the references of the datums that have been managed have been used in the last years was ED 50, European datum 50. Then a reference system is defined by the coordinate system and the datum, and there are different reference systems for each area in the world. We can have ED 50 as we saw, or ETRS 89, that is a current projection reference system, for example, in Spain, in Europe, but in this moment in Spain. And here we have how the global coordinate system works. We have latitude and longitude from the equator, and the meridians from the equator and the parallels in the north or in the south, and the longitude, the east or the west from the Greenwich meridian. Here we can see in a local area, these countries, we can see this area is longitude east from 34 to 42, and the latitude north from 29 to 37. This is the area, that area. The projection is a bionic relationship between the points of the terrestrial surface and the points of this projection flat, at the projection flat. So we can have different systems, different projections depending on the figure where it's projected. For example, we have a flat one, a flat projection, a conical, cylindrical, and this one, the cylindrical, is used for one of the most reference system used in the world. It's Universal Transfer of Mercator, UTM, and it has 60 zones divided in 6 degrees every one, from the east to the west, from the west to the east, sorry. So each area is 6 degrees of longitude. Here we can see the world, the whole world, and for example, in the case of Spain, we can see this area, this zone. Almost all Spain is in the zone 30. So, and there are several regions that are in the 29 or 31. For example, when we work with the whole Spain, we usually work in zone 30. But people from Galicia, or when they work with their local cartography, they work in zone 29. Here we can see the UTM coordinates. The center of the meridian, of the central meridian, the coordinates is 500,000. So we have less than 500,000 to the west, and to the east we have more than 500,000. So there aren't negative coordinates. The same for the latitude. The equator is 4 million, so we have more than 4 million to the north and less than 4 million to the south, but no negative coordinates. It's the same for the 60 zones that the Earth is divided on. We also can transform from different reference systems. If we reproject from one reference system to another one, sometimes we have to apply transformations, because if we don't apply them, we can get an error, so we can see both layers overlap correctly. One of the ways to manage the reference systems is through the European Petroleum Survey Group, or EPSG. This organization has a set of codes for the different reference systems depending on different parameters. For example, here we can see the different codes depending on the datum and if it's UTM, north or south, if it's geographical coordinates, etc. So we have the EPSG codes that can be managed in GBC. Here at this link you can find all the codes, the EPSG codes that are available to be managed from GBC. In GBC we have the reference system of the view that we can see here, and we can change this reference system. From this option, we can look for the different codes depending on our area or our cartography. In this case, for finishing, we can see a reference system, a view in a concrete reference system, and two different types of cartographies. We can see that they aren't overlapped correctly. So one of them, it seems that one of them is correctly in the reference system of the view, and the other one hasn't been reprojected or hasn't been reprojected correctly. So we have to take this reference system into account, the reference system of the view and the reference system of the different layers that we are loading in GBC. And with this last slide, we are finishing this second video, and the next one we will start with the practical exercises. See you at the next video.